Hi everyone and welcome to the Transport Canada Expo here in Ottawa, Ontario. We've come from Hamilton, Ontario today. We're here with Mohawk College Unmanned Remote Sensing Innovation Center. Let's go take a look around. All right, we're here with Omar from AVSS. He's an integration engineer. Omar, tell us a bit about why you guys are here today.
So we're here today to show off our PPDS, which is a precision payload delivery system. We use it to drop packages from drones and autonomously guide them using a parafoil.
If someone's going to buy this system, what are they going to be using it for?
So they're going to be using it for emergencies, timely deliveries, maybe survival kits, delivering food or blood or anything in an emergency.
In addition to the payload you have to drop, you also have a parachute for the drone. What's the acronym for that and how does that work?
So the acronym is a PRS. It's Parachute Recovery System. So it sits on top of the drone and it's recording the flight of the drone and detecting if there's any failure. So if there is a failure, the system will automatically deploy a parachute.
All right. Well, thank you, Omar, for interviewing with us. And we're here with Enrique LaFlamme, the president of LaFlamme Aero. Enrique, why don't you tell us a bit about why you're here today and what the tech is you're showcasing?
Yeah, we are demonstrating the LX300. It's an unmanned helicopter with 180 kilogram of payload capacity. You can do missions up to 10 hours or with 180 kilogram of payload capacity. Then it's a trade-off between endurance or payload weight.
And so our small RPAS are around 400 feet AGL and below. Manned aircraft are, when we say minimum 1,000 feet, usually once they're up in the air. Where does this aircraft lie in that operational space?
Short-range deliveries, last-mile deliveries with low altitude, or we can do surveillance mission at high altitude. It really depends on the application that we are using the same system.
Okay. All right, now we're here with Nikita, who is the CEO and co-founder of Skygauge Robotics. Nikita, why don't you tell us a bit about what you're here today doing and what you're showing off?
In short, we have reinvented the drone to perform a wider range of industrial work. So our first use case is doing industrial ultrasound, but from here we plan to branch out into things like painting, pressure washing, cleaning, scrubbing, sanding, high-rise window washing, and all manners of physical work. Our vision is to create a workforce in the sky. So drones today were really designed as the most mechanically simple way of getting an aircraft in the air. Those design choices made it inherently unstable because it flies by tilting the entire body to move in the direction that they want to go.
Right.
But this creates a lagging motion when you want to do an action and then you actually completing that action. So by using this type of a system, you can instantaneously modify the direction and the force on the surface. And additionally, what that allows you to do is to also apply a force and maintain absolute control while applying that force.
Joining us now is Luke from Provectus Robotics. He's a developer on their team. Luke, why don't you tell us a bit about some of the tech you have here today?
Yeah, so we've got a few different chassis that you can see. We've got the car, we've got, this is what a Mission Master, it's an engineering version of a Mission Master, and then we've got a Polaris M-Razor out in the field. Everything is running the exact same software. It's our proprietary software package that goes onto any vehicle and turns it into an autonomous system.
Okay. And so primarily you're making the software to drive these autonomous vehicles and getting the sensor set up for them?
Yeah. So we deliver what we call an A-kit, which is an autonomy kit. So it's computing with software and sensor package that goes on to the vehicle. We're vehicle agnostic, sensor agnostic. So somebody will come with us with a problem, or they have a chassis that they want to automate, and our software goes on that vehicle.
Yeah, so it's like a 8-wheeled truck. You have regular cars. You have kind of ATV military style. What other platforms have you developed this tech for?
So we've done 3 different autonomous tanks. We've done the large military, those big logistics trucks. Yep. We've done a few smaller guys, but typically this will be the smallest kind of chassis that we would work with. So it's kind of this size and up. So a small car and up.
Great.
Yeah. So we do really 2 different streams of operation. So one is the dismounted soldier support. So this type of vehicle will go with the soldiers in the field. They can put their gear on it, and it'll do follow me. So I'll actually just demonstrate. Just do a quick demonstration here. So it'll do like, it'll follow you when you go out, right? It'll record its path, and when you get down range, you can click a button and it'll drive back to where it started. So the idea is they take their gear, they put it on, then it follows them, and we're talking 2 or 3 kilometers, like a pretty long ways. It'll record its path, and then you click the button and it drives back, and then at the home base they can load more gear and kind of come back and forth like that.
So really the name of the game is keep things simple, keep it easy to use for the end user.
Yep, absolutely. Yeah.
All right, now we're here with Luke, who's the account executive at Indro Robotics. Luke, why don't you tell us a bit about your role at the company and some of the tech you have you're showing off today?
Yeah, so at Indro Robotics, we kind of focus on connected drone and ground robots. So all of our robots we strive to use over either a 4G or 5G connection, or have them operate autonomously. Mm-hmm. So what we've got here, for instance, is we call it Sentinel. So Sentinel is built for critical infrastructure inspection. But also security monitoring and emergency response. So something like this lives on site. It travels between inspection points, takes the same picture every day. You can also do autonomous patrols, but be logged into if an alarm's tripped to see, what it was, a trespasser, an animal, something of that nature. And then kind of the last part of it is the emergency response side, where it's like there's a natural disaster, a fire on site. Let's see just how bad it is and how many people and resources we need to deploy to solve that problem.
Okay, and so what do you see some of the benefits of having 4G and 5G enabled robotics?
So 4G and 5G in general enables real-time data transfer and also super low latency. So if we want drones to fly over cellular connections, we want a very solid connection to ensure we don't lose control of the drone midair. And then on the ground vehicle side, it's all about providing that intel and that data in real time. And that's what really gives our solutions a competitive advantage and makes them actually practical in the workplace.
Okay. All right, we're here with Morley Wallace, the owner of GPS Ontario. Morley, why don't you tell us a bit about what you're here today, what kind of tech you're showing off?
Well, today we're actually promoting a new method of growing a crop, and this method is what we're calling innovative fertile stripping. And while we're making that strip, we're actually putting fertilizer in that strip at the same time. So one process creates the strip, blends in the fertilizer, and lays it back down again. So 24 hours later, 48 hours later, we'll come in with the corn planter. Because we have GPS on the tractor, we're actually able to relocate that strip that we have put there and put the seed down in that strip approximately 2 inches down.
Great, I think I learned a lot, and thanks for interviewing with us.
You're very, very welcome.
And we're here with Robert Peaker from Nokia. Robert, can you tell us a bit about why you're here today and what tech you're showing off?
Absolutely. So my name's Rob, so I'm from Nokia. We have the Invest Ottawa Mobile Command Center van standing behind me. So it's a modified Mercedes Sprinter van. It has private LTE and private 5G technology on it. And the main idea is a concept such as, remember we had the derecho back in May, the big windstorm that knocked out power all across the province? Well, in those cases, your traditional service provider networks go down. Then you need a private network that you can operate that runs independently from the public networks. So that's what we have in the van. The van concept is you drive the van to an emergency location, you would erect the mast, we have 4G radios, we have 5G radios, and we can create a private coverage bubble in the area of the incident for emergency first responders to communicate with.
All right, well, there we go.
Yeah, so part of it has been, solution space. So it's, we have these large platforms that we have to test. We have the Copperstone, which is an environmental robot that can travel on both the ice and the water, right? So it's like, well, what are you going to use it for? Well, I've not single-handedly, but I've participated in rescues where vehicles have gone through the ice, and it's like, that's a problem. And especially now everybody knows about environmental concerns and warming, and these arteries are necessary in First Nations and Indigenous communities. And so if we can sort of mitigate some of those problems by sending a robot out like that, but in order to test the ice roads, what do we have to put on it? Well, we got to put an auger on it. So we got to get a little drill that's there, and it has to go down, and it has to determine the ice thickness, and it needs to have some kind of a software on it that can post-process, that can transmit back so that we know what's going on.
So you're finding new use cases for the tech. You said the regulatory compliance as well?
That's our job. Yeah, our job is to anticipate some of the issues that they're going to have. And so this is a Canadian innovation called Copperstone, and they're located in Edmonton. And so they were part of this program to try to innovate and bring these technologies to industry. And so it's a pathway to commercialization. So they had the insight and wherewithal to kind of develop it. We kind of hopped on to say, well, what can you do with it? What are the applications, and how can we get into the communities and make it useful so that they would want one and it can help with some of the problems that they have.
All right, folks, thanks for watching and learning about all the exciting new tech we covered here today at the 2022 Transport Canada Expo.